All right, we've reached the point in Advent of Code season where I'm starting to get tired uh, of it, but there's only this many more days, and hopefully they will go pretty smoothly. I've got them all done so far, so uh, hopefully tonight is another. Hopefully tonight is a good night. I don't see another good night. They haven't been that good the last couple of nights, but hopefully this one is a good one. Um, and we will find out in about 10 seconds. So you approach Neptune, a planetary circulation system, and text activates giant tractor. You on Triton, you have to choose the land to scan the local area, reveals only one interesting feature, massive underground vault. You generate a map of the tunnels, your puzzle input. The tunnels are too narrow to move diagonally. Only one entrance is present among the open packages. Stone walls detect some sort of keys, shows locates letters and doors. Keys of a given letter open the door, same letter, A opens A, B opens B, and so on. You're not sure which key you need to disable the tracker beam, so you need to collect all of them. For example, suppose you have the following map. Starting from the entrance you can only access a large door and a key. Moving towards the door doesn't help you. You move 2 steps to collect the key, unlocking A in the process. You move 6 steps to collect the other key B. So collecting every key took a total of 8 steps. Here's a larger example. A reasonable move is take key A and unlock door A, then do the same with key B, and the same with key C. You have a choice between keys D and E. While key E is closer, collecting it now would be slower in the long run than collecting key D first, so that's the best choice. Finally, collect key E to unlock door E, then collect F, taking a grand total of 86 steps. Here are a few more examples. Shortest path is 132 steps. Shortest paths are 136 steps. Shortest paths are 81 steps. How many steps is the closest shortest path that collects all the keys? Okay, presumably there are okay, so that's a big map. So let's think about this. This is going to be a little bit tricky. So one thing I can do is I can basically run a depth first search, and at any point I can find all the keys, and then uh, uh, so let's think about this. Shortest path is 81 steps. So shortest path to collect all the keys. So let's look at this one because this looks sort of like that one. I can get, so starting here, I can find, here's how to get A, here's how to get B, here's how to get C, here's how to get uh, D, here's how to get E, here's how to get F. So A, F, B, J. Okay. So the key, so one idea is that whenever I collect a key, that door disappears. Okay. And um, so once I collect A, the thing A vanishes. And I want to um, see, so there's 26 keys, which means that there's like 26 factorial different ways, and there are not so so let's just say from typing import list, and grid is going to be a list of strings, and you know, named tuple, and let's just say class xy named tuple. X is an int and y is an int, so I'll use that to keep track of positions. And class state named tuple is going to be a position, which is an xy, and it is going to be a keys is going to be a dict from from pause to string, dict from xy to string, and let's say doors is going to be a dict from xy to string. I may want this backwards. I have to think about it. I don't. It probably doesn't matter that much. Yeah, that'll be fine. Okay, and let's say def parse raw string goes to a grid, and that's just going to say return list row for row in raw dot split on new lines. That's fine. And def find all keys given a grid, which is a grid, and actually I don't even want a grid. I'll deal with this in a second. And let's do a set. So I want to find all keys given walls, which are a set of x, y. So that's where the walls are, and then a state, which is a state. And it is going to return a dictionary of x, y, it's going to return a list of tuples of a position and what's the name of the key and what's the distance. Class found key named tuple is going to be at let's see, location is xy, name is a string, and distance is an int. So I'll just do is going to be a list of found key. And what I want to do is from collections import double-ended queue. Frontier equals double-ended queue. And let's give it, what are we going to stick on the queue? We're going to stick a distance 0 and a position, which is state.pause. And what I want to do is while frontier, num steps, say result equals this, num steps, let's say location xy equals frontier dot pop left, and I don't want to visit the same place twice, so I'm going to do visited, and then let's say deltas equals 0, 1, 0, minus 1, 1, 0, minus 1, 0. So for dx, dy in deltas, let's say new pos equals x plus dx, y, new pos equals xy, x plus dx, y plus dy. And if new pos in visited, I just continue. If new pos in walls, continue. If new pos in state.doors, continue. If new pos in state.keys, so that means it's a key. Key equals state.keys, new pos, door equals key.upper, which I think is what they said, right? And actually, I don't even need that. Let's just say results.add found key, what did I call it? Location, name, distance, new pos, key, num steps plus 1, and then I just want to continue again, because I might want to go to the other rows, and then otherwise it's just a new location, and so I want to do frontier.append num steps plus 1, new pos, and visited dot or new pos, right? And then finally, return results. So And now I need to write that parse, and def parse raw string, and it's going to return several things. It's going to return it's going to return a set of xy, which is walls, and it's going to return a state. And so lines equals raw dot split raw dot strip dot split on new lines. And let's say walls equals set, keys equals this, doors equals this. Lines equals this. So for I line in enumerate lines, for JC in I'm going to get my x's and y's mixed up, but that's okay. Enumerate line. And now let's go back and look at what these are. If it's a pound, if C equals pound, walls dot add xy ij. Otherwise, if C is at, let's say pause equals none, pause equals xy ij. Otherwise, if C is lowercase, so A is less than or equal to C is less than or equal to Z. Keys xy ij. Let me just do this. Pause. Loc equals xy ij. Walls at loc. Pause equals loc. Keys loc equals C. If A is less than or equal to C is less than or equal to Z, doors loc equals C, and that's it. And so now I want to return walls state of pause keys doors. Pause keys doors. So let's try that on one of these simple ones. So let's try raw equals this. Run day 18.py. Did I not close things properly? Parse raw, and it returns a bunch of walls, and it returns a guy who's at 1.5, and keys are at 1, B is at 1.1, A is at 1.7, and there's a door at A. Okay, and so walls state equals parse raw. Parse raw. find all keys, walls, state. Results dot append. So find a key at 17, name a distance 2. Find a key at 17, name a distance is 4. So distance 2, how do I get distance 4? Is that because I print num steps x, y visited? So I go left and right. Visited 1614, visited 15. So after 2 steps, I can be at 15, even though I visited 15. So that check is not correct. Let's think about why that is. So I go 1, 4, and 1, 4, because I need to set let me start it with I've been there. So okay, so now I found one key and A is distance 2. And let's try one more. This one there should be more keys to find. So let's say 2 state 2 equals parse. Find all keys walls to state 2, and it finds A, B. So let me, actually I have it right here. So starting here, I can find A, G, B, and F at distance 3, or 1, 2, 3, 4, E, C. Okay, so this seems to be doing the right thing. So I feel pretty good about this. And I'm going to drink some soup. Although I spent 20 minutes on this. This is long. Okay. So here's the idea, is that this is going to be kind of a breadth first search on top of the breadth first search. So in other words, I know that I can collect the keys, and now I need a priority queue where I'm going to do the following. I am going to figure out all the places I can go. I'm going to maintain a priority queue with the shortest path. And I'm going to basically say, okay, so going back here, here are the keys. So I have this subroutine. Now what I can do is I can say, let's put each of these keys in a priority queue with the distance. and with me collecting that key and being where that key is at. So I create a new state where I'm there, and when I collect the key, that door is going to, I'm just going to make it disappear. So that'll be part of my state as well. And now um, I am going to uh, pull off the first thing in the priority queue, which is the closest one. And then I'm going to rerun this thing I just did from there and find out what are all the keys I can get to from there, and throw them all on the priority queue um, as well. Um, and then uh, when I get one where there's no keys left, um, then or then so hopefully that will work. So that's the idea. Okay, so let's import heap queue and def find shortest path, and again it's going to take walls and estates. And it's going to return an int. Okay, and so what I'm going to do is I'm going to say pq equals this guy. Okay, and while pq, and it's going to be path length, and let's say states. Let's say num steps state equals heap q dot heap pop the smallest item off the heap, pq. Okay, and priority queue like allows you to give a score, and it'll just take the lowest one and so on and so forth. And now if not state dot doors, so if there's no doors, that means that we've collected every key, and because we're popping them off in shortest order, I'm just going to return number of steps. Okay, so if the state has no doors, I return the number of steps, and I'm good. Otherwise, what I'll say is found keys equals find all keys, walls, and states for, and what does a found key look like? A found key looks like loc name dist for loc name dist in found keys. Okay, new state equals this, and then heap q dot heap push of num steps plus dists. That's how far we have to go. And new state. Okay, so what is new state? Equals state of, I hate that autocomplete for new tuples, that's terrible. New pos, new keys, new doors. New pos, new keys, new doors. And new pos is just going to be the location of that key. And new keys equals loc key for loc key in state.keys.items if key is not equal to name. So I just want to remove that, and new doors equals loc door for loc door in state.doors.items if door is not equal to name.upper. That gives me a new state, and I push that. So so I think that's pretty good. And now so let's run this. Find shortest path, walls, state. And print num steps state. Oh, duh. PQ equals 0, comma state. That makes more sense. Heap push expected 2 arguments. That is true. Heap q dot heap push. I need to say push this item onto the PQ. Okay, so this is saying that for that one it's 2, and was that the right answer? Then you can move 6. So collecting every key took a total of 8 steps. Okay, so that should be 8. So that means we got the wrong answer. That's fine. Let's say print PQ, or no, print num steps state. So let's try that. And I don't want to print the thing that I'm printing up here. Okay, so okay, so I should be checking for no. I need to collect every key even if there's no corresponding door. So no door, no keys is the correct stopping condition. So let's try that. And now it says 8. Find shortest path, walls to state 2. Less than not in num steps plus dict, num steps plus dist, new state. So somehow that print num steps dist. Let's see. What is it not liking? Let's do print for P and PQ, print P. So let's try this again. can't see anything without the blank lines. So 11 state keys, 9 state keys, 9 state keys, 11, 11, 11, 9, 9, 9, 9, 9, 9, 9, 9. So is this not working? Let's Google it. Heap Q. Tuples are compared position by position. If they are not equal, then the second item is considered. The first item is not unique, so you make sure the preceding items are comparable. Um, uh, I see. Okay, well, I'm glad I Googled that. ID of new states, and so then I just need to throw it away down here, and now I don't want to print all this stuff. Oh gosh, this is going to be too slow, isn't it? Print len pq. We can just watch that. Yeah, so, okay, so this was not a great idea, clearly. So let's go back to the drawing board slightly. And I'm a little bit surprised that it's doing that. Print, let's say len of PQ, name, I feel like there's a bug. Num steps plus dist and state dot keys dot items. So len of PQ, name, num steps plus dist, and then state dot, how is that state dot keys dot items? Oh, because I don't want items, I want values. If len PQ is bigger than 100, let's just say break, or let's just say return. So in 3 steps, I can do all those things. In 5 steps, I can do all those things. And now I have basically one where I chose something's missing here. So this one I took must be building off the G, and um, now I add an A. Here's a bunch where I'm building off the G. Um, and there's just this combinatorial explosion where it's not working. So um, it's like once I take A, then it's basically I have each of these 8, and then for each of those, I have um, basically another 7. So it's blowing up factorially. Um, so we need to, so the naive way is not good. Um, so like if I do A, F, B, J. All right, let's see how many people have solved this so far, so I can feel bad about myself. All right, 7 people have solved it so far. So someone got the first star in 10 minutes. That's pretty good. Um, so let me and so here the shortest path is 136 steps. Um, and it's just chewing through these things. It's just gonna run for a long time. But I feel like it's getting there. Um, but now the queue is getting longer and longer. It's got like 1 million to consider. Um, and you know, if I had 26, it would um, run that much worse. All right, so this is bad. Um, so let's think about a different approach, um, which is I do forget about my subroutine. I just do a pure breadth first search where um, where whenever I pick up a key, I wipe out my visited. Um, and uh, I still do a priority queue by num steps, but no, I don't do priority queue by num steps. Um, so I start, I find all the keys, and then for each of those, um, I basically start over. Um, and well, that's what I'm doing right now, actually, is that but let's say I start here and I go to B, and then once I get to B, um, I wipe out where I've been, and I can just keep going. Um, and my priority queue is going to be distance. So um, let's try that way, see if it works. Probably won't work, but um, let's find shortest path to walls, state, um, path length 0, state, um, state dot pause, blank state visited. Um, and so while PQ num steps state visited equals that, um, if state has no keys, return num steps. And so now, instead of doing that, what I'll say xy equals state dot pause. For dx, dy, and deltas, new pause equals xy, x plus dx, y plus dy. And again, if new pause in walls, continue. Otherwise, if new pause in state dot doors, continue. So this is like almost the same logic as above. Elif new pause in visited, continue. Otherwise, if new pause in keys in state dot keys, then I want to do one. I'm going to say key equals state dot keys new pause. New keys equals loc k for loc k in state dot keys dot items if k is not equal to key. New doors equals loc d for loc d in state dot doors dot items if k is not equal to key. And then wipe out visited. Actually, no. Replace visited with current location. New visited equals new pause. And then let's say new state equals state of new pos, and then state is new keys, new doors. And then I want to say heap queue dot heap push on the party queue of I took a step, so that's num steps plus 1. ID of new states. New state and new visited. So I push that on. And then otherwise, just take a normal step. New visited equals visited or new pause, and then heap queue dot heap push of pq, again num steps plus 1, ID of states, state new visited, and all right, let's try that. So print num steps state visited. Okay, so doors keys equals AB, keys equals AB. 1, 2. So it's not removing the keys. So why is that? New keys equals location key and state.keys.items if okay, 1, 6, 1, 4, 2, 5, 0. I don't feel like those are even allowed, basically. Oh, because those are just walls. Because it's not moving at all. Why is it not moving at all? Oh, I know why. Because new new state equals state new pause keys state dot keys state dot doors. That's stupid. So let's do new state new visited. Okay, so k is not defined. If d is not equal to key dot upper, let's try that now. 8. Okay, so let's see if this works. It probably is again going to be too slow, but okay. The queue is still growing like crazy, although it's picking things up slightly better. Um, um, so what if I just do this, and that's just the number of keys? What if whenever there's a tie, I pick the one that has um, the least keys? So, um, so before I do this tiebreaker, I do len of state dot keys dot values. So now, whenever there's a tie, it's going to pick the one that has the fewest keys. Too many values to unpack. Expected 4. I don't care about that either. a lot less printing now, but it's still a little bit out of control. All right, so we've been going on for an hour and we're not making any progress. And there's always one problem like this where like conceptually I'm doing the right thing, but it's not performant enough and I'm not going to figure out why. So I'm going to stop recording.